All right, so sampling methods. Again, it'd be nice if we could know things about the entire population, but usually we can't. Usually we have to sample a subset of the population, and choosing how to find that subset, choosing what subset to ask, there are different methods for that. So let's talk about some of them. So these are going to be kind of informal descriptions, but you can find more formal ones in the textbook. So to start off, a census is just ask everyone. This is the whole population. And I'm going to say ask, but every time it's asked, we could ask or measure the whole population. So in general, a census is not very feasible, but it gives you very, very good data. If you do a census, then you have the population parameter. You have that P proportion or mu population mean. And this is great. So in this example, if we're surveying SPSCC students on how much they pay for housing, this would just be ask every SPSCC student, which would be difficult. All right. Not to mention, I'm sure some people wouldn't want to answer, and it would be very hard to ask everyone. Okay. So simple random sample is the next one. And this is kind of what it sounds like, although sometimes it's not as simple as we might want it to be. But this is basically get a mathematically random. So that's kind of an important part, because humans, like we usually say the word random all the time, but like this means really like mathematically random, like very random. Very randomly select. So maybe this could be with like a random number generator. You can also kind of simulate this without a computer by picking names out of a hat. So maybe in this example, if we want to do a simple random sample of SPSCC students, maybe we could just randomize a list of the student IDs. Okay, we could randomize a list of student IDs and then choose the top 100 or something like that. That would be an example. One example of a way that we could do a simple random sample over here. So stratified and cluster, these next two are kind of similar in a way because they both involve splitting things into groups. Okay, so both of these, we're going to start by separating the population into groups, otherwise known as strata. That's not how you spell that word. And that's actually going to be for both of these. So let's kind of do both definitions at the same time. Separate population into groups, also known as clusters. So we can call the groups whatever we want, right? And they're usually called strata for stratified and usually called clusters for cluster. And then what we do after that is where it's different. So in a stratified sample, we're going to then do a simple random sample within each group. So this right here is my shorthand for within. So random, separate into groups, and then this ensures that we ask people. This ensures that our sample has the right number of people from every group that's giving a response. Okay, so maybe for SPSCC students for housing, we could do it by gender, we could do it by race, we could do it by, whatever we wanted, age, etc. And we could separate that depending on, kind of what's the data that we care about. What kind of variables are we curious about a distinction here? It's okay. So maybe we separate it by age. Okay. Maybe separate by age. I'll have 17 minus 18 to 25, 26 to 35, 36 to 50, I don't know, 51 plus, whatever. Separate into groups. And then within each group, we will sample a proportionate amount in each group. Okay. So we're not going to ask the same, because these groups are very different for SPSCC students, right? There's a lot of the most SPSCC students are in this range, but not everyone is. There are students in all of these ranges. And so we're going to make sure that most of the things that we ask are going to be from this, but then we'll ask a proportionate amount in each group. And then clusters, you still separate into groups, but then you ask everyone. In a couple groups. And it depends on how many groups you want to ask. So here, right, we're going to do the same thing as before. Separate into the same groups, but then what's different is we'll sample everyone from 2 random age groups. So this method of stratification doesn't really make sense for the clustering, because I guess it could, right? This would give us a lot of data on specific demographics of students, and again, the variable that we're measuring is the rent. Okay, so this would give us a lot of data on some of the groups. Okay, so it could be useful. Cluster sampling can also be helpful for convenience. Like if we're curious about something in all the restaurants around town. Like we had an example where the average shelf life of apples. Well, we had to do that for every restaurant, if we did a couple from every restaurant, there'd be a lot of travel. But if we did cluster sampling, then we just choose a couple grocery stores. Choose a couple grocery stores, and then we don't have to drive as much, for example, is one advantage to clustering here. All right, 2 more, systematic and multi-stage. Systematic is going to be essentially picking a random start and then doing every nth. So like every first, every second, etc. Every nth, depending on size. So maybe we order everyone by their student IDs. Oh, let's write this, right? Order students by your student ID. Use a random number generator to pick a random one. And then basically every 10th student ID after gets asked. That's an example of systematic. And the last one is multi-stage, which is exactly what it sounds. Okay, so a combination. All right, so maybe we systematically choose a group and then do a simple random sampling within that group. Okay. Maybe we'll do systematic every 3rd person, and then simple random to narrow it down further. All right, and that's basically sampling methods.